Okay. An applied force of 20 newtons accelerates a block across a level, frictionless surface from rest to a velocity of 8 meters per second in a time of 2.5 seconds. Calculate the work done by this force. Now, stay with me. I'm going to do this question in two different ways. So first, let's look at this in terms of intuition, right? No formulas for distance needed. So let's look in terms of kinetic energy, right? The work done by a force on a frictionless object goes entirely into changing the kinetic energy. So work is equal to the change in kinetic energy. We can write that right here. Work is equal to the change in kinetic energy. The initial velocity here is 0, the initial kinetic energy is 0. The final velocity here is 8, the final kinetic energy is 1/2 m times 8 squared, which is 32 times m. We don't know what m is yet. So, how do we do that? Well, let's relate mass to the applied force. From Newton's second law, we can see that F equals ma, so that means m is equal to F over a. We know that from V equals AT, A is equal to VF minus VI divided by T, right? The average velocity, which is equal to 8 divided by 2.5, which is equal to 3.2 meters per second squared. So m is equal to F over A, which is equal to 20 over 3.2, which is equal to 6.25 kilograms. Lastly, let's compute the kinetic energy. Kinetic energy is equal to 32 times 6.25, which is equal to 200 joules. So what did we do here? Without even calculating the distance, we can see that the force goes to acceleration, which goes to mass, which goes to kinetic energy. This is really neat because on a frictionless surface, the force always goes into speed. No distance needed if you know the final velocity. However, let's do this a different way now. So let's go step by step and we'll check conceptually and numerically. We're asked work done by a constant force on a frictionless surface. We don't know the mass, but maybe we won't need it if we use work equals force times distance. So we can do it a different way. First, let's find the acceleration. Newton's second law states F is equal to ma, which shows a is equal to F over m, but we don't know m. So what do? Well, we can use kinematics, just like we just did previously. V final equals V initial plus AT, which shows us that A is equal to V final minus V initial divided by time, which is equal to 8 minus 0 over 2.5, which is equal to 3.2 meters per second squared. Now what do? We find the distance traveled. For a constant acceleration, the distance traveled s, or delta x, is equal to vi, initial velocity, times time, plus 1/2 at squared. We can plug these in as this. S equals 0 plus 1/2 times 3.2 times 2.5 squared, which gives us 10 meters. Now third, lastly, we need to find the work done by the force. The work done by the force is equal to the force times the distance, s, which is equal to 20 times 10, which is equal to 200 joules. So notice how we both got the same answer in that way. Now, that's perfect.